Okay, so we're just going to continue on where we left off. I didn't want to make the video too long for you. So we're going to start with our tables, and we're going to look at each of our different types of graphs here. So the first one that we're going to look at is degree 1. Okay, and if you'll remember from our last thing, we talked about a degree 1 was linear. And its basic equation or standard form, and I'm going to write it the way our standard form is, and I'm going to go ahead and give you the others, so just remember y equals mx plus b. Now, I will tell you, if you're using your graphing calculator, a lot of times they will write it as ax plus b, so that it fits more into the pattern of our other standard forms. Okay, so an example might be something like 2x plus 3 equals 6. That would be a standard form. Of course, we could write it in slope-intercept. I don't have point slope written down, but we could also do it slope-intercept. Okay, so let's talk about what the graph looks like. So I did go ahead and leave it as an A, because then that's what all of our other graphs are going to be. So we're talking about A as being our slope. So I'll note that up here. MA equals slope. Okay, however you want to do M and A or however. Either one of those are your slope. So if I have a positive slope, what's the graph going to look like? And hopefully you know what a positive slope line looks like. We're going to have something that looks like that. Now, we do call this a lot of times an oblique line. Okay, so just know a positive slope, oblique line. Next one, if we have a negative slope, okay, so what should it look like? And again, hopefully you know it's going to go down left to right. So I'm hoping none of this is messing you up or confusing you. This should be a given at this point. The next one is when our slope is 0. What kind of line do we have? Okay, and it should be a horizontal. Okay, and then of course we have our last one I went ahead and put in here is what happens when our graph, when the slope is undefined. Now, it is a vertical line, has an undefined slope. And we don't talk about the vertical line a lot because it is not a function. Okay, not a function. So those are our 4 types of graphs that we have with lines. Again, hopefully that is nothing new to you at all. So now the question is, in a new vocabulary that we start talking about is what's the end behaviors? And so the end behaviors is what's the graph doing on each end. Okay, and so what you're going to see is it written this way. As x approaches positive infinity, and a lot of times you'll see it written this way. Okay, that's the way I'll write it on the board. As x approaches a positive infinity, in other words, as x is going this direction, what is your y doing? Okay, well, it is continuing to go up. Right? It's going to get higher and higher. So we say as x approaches a positive infinity, y approaches also a positive infinity. Or you might see it written this way. Does that make sense? As I'm going this direction, okay, I'm going up in both positive and negative. Okay? And if something of this doesn't make sense, be sure you do catch me and we can talk about it. So then the next one says as x approaches a negative. So as I'm going this direction on my x, what's my y doing? And hopefully you see it is going down. So y goes also to a negative infinity. Okay? Okay. Then when we have a negative graph, okay, so again, I say as x approaches positive, what's y doing? Well, y is going down. So as f of x approaches positive, y approaches negative infinity. Okay. So again, I'll go ahead and write it. I like writing it this way. As x approaches a positive, y approaches a negative. Okay, I didn't quite leave you enough space on the bottom. Next one is as f of x approaches a negative. So that means I'm going this way. My x is going negative. What's y doing? And in this case, it's going positive. So as as x approaches negative infinity, I messed that up twice now. As x approaches a negative infinity, y approaches positive infinity. Now, what I want you to do is look, because we're going to start talking about a pattern here. Okay? Now, in this case, as x approaches positive, as x is going this way, what's happening to your y value? Okay? Well, it is staying constant. Okay? So it is approaching, it is constant. And that constant is whatever value that we have. So as x goes this way, your y is staying at whatever value this is. We'll call it k, okay? It's going to stay at that value. It's not going to change. Same way, if it goes to the negative infinity, it's going to keep approaching that k value. It's going to stay at k, okay? Vertical, again, a lot of times we don't talk in behaviors just because it's not a function, but you could, as you approach, as you're going this way, where you're not really going to go this way, are you? So it's kind of hard to say as x approaches a positive, because x is never going to go that way. So again, this is not a function. We're really not going to talk about those. And in particular, we're, for the most part, not going to talk too much about horizontal lines. It'll mainly be your positive and negative lines. Okay, questions about that? Okay, if you have any questions, please note them somewhere on your paper if something doesn't make sense, okay? So we're going to go on then to our quadratics. Okay, a quadratic is of degree 2. Okay, again, it's called a quadratic. Its basic form is ax squared plus bx plus c. Okay, and again, an example might be, x squared plus 2x minus 3. It could even be something x squared minus 9. So we could have multiple things there. Okay? So we're going to talk about our quadratic and what happens if a is greater than 0. Okay? And we do have several options here on a greater than 0. So I'm going to draw, let me go back here and use my same colors I was doing. I'm going to draw somewhat what our graphs could look like. So what a is greater than 0 is going to tell us here is that our graph opens up. And we should know that the graph, I'll put it up here, is a parabola. Okay? Now, but what could it look like? So I'm going to give you some examples. One is it could be opening up, looking something like this. And we would say that this one has 2 real solutions. Okay? Now, that could be fractions, because fractions are real numbers. But, you could have this, let's say, crossing at a -2 and 3. Okay, that is 2 real solutions. I can factor it, or I can run the quadratic, or I can complete the square, but I'm going to get 2 actual values. Okay, our next one that we're going to look at, oops, I meant to do that in purple. Color code these a little better. Okay, so our next one could be where it just touches and bounces. Okay, so in this case, let's say that that's a 4. So this has, again, 2 real solutions, but in this case, it's a multiple root. Okay, I'm going to go over here and put, just for the sake of it, write it in blue. This would be, if I give you that one, that would be x plus 2, x minus 3 equals 0 when I solved it. So what this would be x minus 4 squared. Okay, that's what that would be. It would be a multiple root. It would occur twice. Okay, our next one that we're going to look at, again, is what happens if it's up above. Now, again, it could be anywhere up above, but it's up above. A being greater than 0, so it's up above, opens up. And in this case, when I'm looking at this one, we would say this has no real solutions. What that means is that this is where when you solve it, you're going to get imaginary numbers, okay? Or what we'd say complex numbers. Okay, so no real solution. You're going to get imaginary numbers on there when you graph that. And remember, your imaginaries come in pairs. So no real solutions, but we're going to have a pair of imaginary. So we're still going to get two answers. So what I want to show you, no real solutions, we're going to get a pair. And let me just put out here. I'm going to put out in front of this. So we're going to get two imaginary numbers because they come in pairs. So if it is a quadratic, degree 2, you will always get two answers. The question is just what kind of answers are they going to be? Are they going to be real? Are they going to be two reals where one of them repeats itself? Or are they going to be two imaginaries? And those are your three choices on there. Okay, so we'll go through the next one real quick because it's just going to be the flip of it on there. So let me get me some pictures here. Again, if it is negative, we know that it is going to open down. So I could have it where it is a parabola that opens down and which it has two real solutions. Okay, I could have it where it opens down where, again, it is, whoops, pretend that's touching up there. It is a two reals, but it is a multiple root. Okay, and then, of course, we could have it where it opens down, doesn't cross, in which it has no real solutions, but it has two imaginary solutions. Okay? So those are what is going to happen. Now, let's talk about the end behaviors, because hopefully you notice in each one of these, okay, as x approaches, as x approaches positive, infinity, my parabola is also going positive. So as x approaches a positive infinity, y is also approaching a positive infinity. And as x approaches a negative, your y is also going up. Okay? And that is true of all of those. Okay? Every one of them is going to look the same. If I go this way, then my arrows are going to go up. I'm going to keep going up. If I go this way, I can see my arrows are still going up. Okay? Now, if I flip it over, as I go to the positive infinity on my x's, so I'm counting, what I mean by that is I'm counting over on my x-axis, then you're going to see my y's are going down. Okay? And again, as you're going to a negative infinity, your y's are also going down. Okay? And that is true about each one of those. And that's what we call our end behaviors. So we talk about what the end behaviors do. If you remember when I stand in class and I point my finger and I'm saying, what's it doing? Okay? So we'll stop right there on those two, and then we'll pick up with the next two types.